All right, so gravity. So we're going to talk about universal law of gravitation today. Gravity is the force that attracts one body of mass to another body of mass. Okay, so you already know how to calculate weight. Okay, so weight, this is Fg, which you know equals mg. Okay? That came from the law of universal gravitation. Okay, so what is the law of universal gravitation? It states that a particle attracts another particle by using a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Super complicated. It can be reduced down to just one formula. Most laws can be described in one formula. The formula for the universal law of gravitation, okay, is Fg equals big G, which is a constant, times m1 times m2, those are masses, divided by r squared. Okay, so let's define these things. So big G, this is the universal gravitation constant. So big G is equal to 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. Constants are simply things to make your math work. This is a constant that's given on your formula sheet. You never have to memorize that number. It's always going to be on your formula sheet. It's on there now if you're looking for it. It's so you have the front of your formula sheet. You know, the top of it has a bunch of squares with formulas. The bottom has a bunch of squares with formulas. In between there, those are a bunch of constants. And there is a big G in there. There's also a little g, which little g is just gravity on Earth. You don't have to memorize that either. This is big G. All right, and then what are the rest of them? So M1 is a mass of one thing. It needs to be measured in kilograms. M2 is the other mass, and it also needs to be measured in kilograms. Okay, and R is the distance between the masses, and it needs to be measured in meters. Okay, so this law is stating that the mass is directly proportional to the force, okay? So M is directly proportional to Fg. And R is inversely square proportional to Fg. That's basically what the law is stating, but they put it in a formula. That's all. That's the whole thing. It's not very hard. Okay, give me just a second. All right, so we're going to do an example problem. Azure is 54 kilograms. I don't really know how much she weighs. I just said that. What is the force of attraction between her body and Earth, and what is her weight? Okay, so to solve this, you need to know the mass of Earth, and you need to know the radius of Earth, because that's the body of mass that Azure is attracted to. So if you look at your green sheet, big G is right there, so we are going to need big G. We also need the mass of the Earth. M Earth is the mass of the Earth, the 5.98 times 10 to the 24th kilograms. And R Earth is the radius of the Earth. Okay, so we are going to use all of that to figure out the attraction. Okay? So, first I'm going to write my formula because I'm looking for Fg. So I'm going to write Fg equals big G M1 M2 over R squared. Then I'm going to plug all those numbers in. So big G is 6.67 times 10 to the negative 11th. I don't really care about the units so much, but let's just put them anyway. Newton meter squared per kilograms squared times Azure's mass, 54 kilograms, times the Earth's mass, 5.98 times 10 to the 24th kilograms. All of that over R squared, so that's the radius of the Earth squared, because that's where she's standing on the Earth. So that's 6.37 times 10 to the 6th meters, and then squared. Okay, so you're going to have meters squared on the bottom and on the top, so that will cancel. You're going to have kilograms squared on the bottom, and on the top you have kilogram times kilogram. So you're going to cancel, that'd be kilograms squared. So then your kilograms will all cancel, and you'll be left with newtons. What is force measured in? Newtons. All right, so then all we have to do is stick all of that in our calculator. Yeah, like that's no problem. All right, let's see if I can get this where you can see it. Maybe. All right. So you're going to do 6.67. You're going to hit second, comma, negative 11. Not minus 11, but negative 11. Okay? And then times 54. And then times Earth's mass, 5.98. Second, comma, 24. Divided by, you're going to put it in parentheses. You have to put the bottom in parentheses. Okay, 6.37, second, comma, 6. Then you close the parentheses and then hit the squared button. Don't forget to square. If you wrote the square then in your math, then you have to square it. And so that is Fg. So then Fg equals 530.8 newtons. Okay? So that's the force of attraction between Azure and Earth. Oops. Now, it also asks, what is her weight? Okay, you remember how to calculate weight. Weight is Fg equals mg. Yeah, that should be easy, yeah. So 54 times negative 9.81 negative 529.7 newtons. What do you notice? Yeah, they're about the same. Okay. The weight formula, this G equals big G times the mass of Earth divided by the radius of Earth squared. That's how we got that number. It is a rounded number when we put it in as 9.81. It's not exactly what the number is, but it's pretty close. And so that's what that is. So this came from the universal law of gravitation, and it's calculating weight.